Okay, Julia, I thought this might be easier if I could just tell you about it. And if you have other questions, just ask me. Okay, so here's the periodic table. And if you get your periodic table out, you can write on yours. So you can pause me right now and do that. But what you're going to do is, if you put on here, these columns, vertical columns, so straight up and down, are called families or groups. And families or groups tell you how many valence electrons an atom has. Okay, and we'll talk about that more in just a second. So everything in this first column, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, are all going to have one valence electron. Your second column, which is beryllium all the way down to radium, are going to have two valence electrons. This area right here I call sunken down multivalence land, because these can vary. So from scandium down to actinium, this whole area in here can vary, and you don't have to know those for 8th grade physical science or 9th grade physical science. So your teacher won't tell you about that, I'm sure. The 13th column over here has 3 valence electrons. And if you look on here, you'll see this has 1A. That means 1 valence electrons. 2A, 2 valence electrons. 3A, 3 valence electrons. This is IV, which is 4. This one has 5. This one has 6, 7, and 8 valence electrons. So that's the columns, okay? The rows, which are the horizontal straight across rows, are going to tell you how many energy levels an atom takes. So the first row has 1 energy level, and that's only hydrogen and helium. The second row, from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, are going to have 2 energy levels. Your third is going to have 3 energy levels, and I doubt that your teacher is going to have you do any more of them, but this row has 4. This row has 5, this one has 6, and this one has 7. And it has the numbers written on there. It's just that you have to know that. These 2 rows down here fit into these 2 rows right here. If you notice, this skips from 57 at lanthanum to 72. That's because 58 through 71 are right here. Okay, and so they pulled them out and put them down here. And then 90 through 103 are fit, that they would fit right in here. Okay. All right. So I'm going to go on to here and show you what's going on with your the thing that your teacher had you do. Okay. So I'm going to go on to here, and I'm going to switch over to Sketchpad so I can write. Okay. And so what's going to happen is on yours, and let me pull this up on my phone really quick. You had lithium. It gave you hydrogen and it gave you lithium, and you needed to know sodium. So it has Na, and then it has 1, 2, 3. Okay. So what I'm going to do is show you how I do it with my students. So you have a nucleus. Okay, and we know that protons go inside the nucleus and neutrons. Okay, and if you look at sodium, so you look at your periodic table, you can see that it's in the 3rd energy level. So that means it's in the 3rd row, so it has 3 energy levels. 1, 2, 3. Okay, now I have my students do something I call PIN. Okay, and if you can always remember PIN, you can remember that tells you how many protons, electrons, and neutrons you would have. The top 2 are always the same as the atomic number. And if you look at the atomic number for sodium, it's 11, and the atomic number for sodium would also be the number of electrons you have, which is 11. This bottom one is the one that you subtract on. Okay, so you take atomic mass, which I can't remember what it is. It's 23 minus 11. So that would be 23 minus 11, which is going to give you 12 neutrons. That's a 2. Okay. All right. So the very first thing I tell my students is place your protons and your neutrons and to mark them out. So this has 11 protons and 12 neutrons. So you're going to put that in the nucleus where they go. And you're going to mark these out because everybody always messes up and uses neutrons for some reason as your electron number. Okay, so it has 11 electrons. We're going to put that number over here. Now your rules are, the first energy level holds 2, the second holds 8, and the third can hold up to 18. Okay? Okay, this is 2, 8, and then 18. That messed up a little bit. Okay, so we know that the first energy level, which is this one right here, the very first one, can hold 2. So I'm going to subtract that because that's how many I'm going to put in there. So 1, 2. Okay, and so then I'm going to I know the second energy level can hold 8. Okay, so we're going to put 1, 2, 3, 4, 5, 6, 7, 8. Now I'm putting them together in twos because it just helps me go back and count. Okay, and I'm going to make these look a little bit more like the other ones. Now, I'm going to subtract those 8 because I need to know how many more I've got to put in this third level. So I have 1 left, and that goes here. Okay, so basically this that he's putting on here are these 3 levels over here. Okay, so what you're going to do is, for yours, okay, you're going to put 2 on the first, you're going to put 8 on the second, 4, 5, 6, 7, 8. Mine's not working out so well. You'll have the computer. 3, 4, 5, 6, 7, 8. There we go. And then you're only going to have 1 on the third. Okay? And if you look at that, the first column on the periodic table, all of those would only have 1 in it. Okay? So let's look at your second one. I want you to pause and try to do magnesium now. Okay, so what you should have done for magnesium, okay, we remember our rules. The first has 2, the second has 8, and the third can have up to 18. I'm messing these up. Okay, so magnesium, you've got to do pen first. Okay, so the top 2 are the same number, and they have 12. The bottom one is 24 minus 12. Oops. I'm not sure what I did there. Let's go back. Okay, so 24 minus 12, and that would also give you 12 neutrons. So here's my nucleus, and you have 12 protons, 12 neutrons. I mark those out, and then I've got 12 to go. So if you're looking at this, like he has, you have 2 in the first, because I have 12 here. Sorry about the noise, my guys are being loud, which gives you 10. I can fit 8 in the second. 6, 7, 8. So subtract 8. And you have 2 left. So that gives you 2. Okay? So, and then that's finished. Okay? Alright, so what he's done is he's skipped. So if you notice on the periodic table how you have this multi-valence land. Okay? He skipped this area. Okay, so he skipped on, when you get to that, boron and aluminum would be right here in column 13. Try it and see if this makes sense, and if not, get your mom to text me, and I will go back and look and see what else I can help you with. Let me see how I can get this. I'm not sure how to get back to my normal screen. Okay, and then here we go. All right, bye, Julia.